In this video, we will take a look at the graphs of quadratic functions. A quadratic function represents the following function relation. It means that when the input value is x, then the output value will be ax squared plus bx plus c, where a, b, and c are constants and a is non-zero. When we learn how to solve a quadratic equation by the graphical method, we have come across this example. We can try to use a graph paper to plot the graph of y equals x squared plus 2x minus 2. It means that the vertical axis is the output value of a quadratic function, and the horizontal axis is the input value. When the input value x is minus 3, the output value y should be 1, and that means we can plot the point minus 3, 1 on the graph paper. Similarly, when the input value is minus 2.5, then the output value should be minus 0.75. So we can plot minus 2.5 and minus 0.75. We can keep on plotting other points, and eventually we will see that it follows a trend like this. And in mathematics, we call the curve of a quadratic function a parabola. This is the graph of the quadratic function y equals ax squared plus bx plus c. First of all, let's take a look at the special case in which the values of b and c are equal to 0. Now let's change the value of a and see how this value will affect the shape of the curve. When the value of a is larger, the curve will be narrower. And when the value of a decreases, the curve will be wider. And when the value of a becomes negative, then the curve will open downward. And when the numerical value of a gets larger and larger, the curve will become narrower and narrower. And when the value of a is positive, then the curve will open upward, like this. Now by changing the values of b and c, I can move the curve to somewhere else, like this. From the curve, we can observe that it is symmetric, and we can draw an axis of symmetry like this. For any shape of this curve, we always have an axis of symmetry. So this axis of symmetry is just a line which cuts this curve into two equal halves. The point of intersection of the axis of symmetry and the quadratic curve is called the vertex. For the equation of the axis of symmetry, it is always x equals the x-coordinate of the vertex, like this. And then the y-coordinate of the vertex is known as the minimum value of this quadratic function. If the curve opens downward like this, now the value becomes a maximum value. So a quadratic function has a maximum value when it opens downward, and it has a minimum value when it opens upward. And this maximum or minimum value is equal to the y-coordinate of the vertex. For the y-intercept of this quadratic graph, it is always equal to c, because the y-intercept is just the value of y when x is equal to 0. So when we substitute x to be 0 in a squared plus b plus c, the value should be equal to c. Therefore, when we change the value of c, the y-intercept will be changed accordingly. And if we do not change the value of c while changing other values, the y-intercept will remain unchanged. Like this. So the value of the y-intercept is just determined by the value of c. And then for the x-intercept of this curve, as mentioned previously, it should be the roots of the equation ax squared plus bx plus c equals 0. And sometimes there can only be one x-intercept, and sometimes there should be no x-intercept. And in most cases, there should be two x-intercepts. So the number of x-intercepts is determined by the discriminant of this quadratic equation a squared plus bx plus c equals 0. When the discriminant is smaller than 0, then there should be no x-intercept. When the discriminant is equal to 0, then there should be only one intercept. When the discriminant is positive, then there should be two x-intercepts. To conclude, for any curve of a quadratic function, when a is positive, it opens upward, and when a is negative, it opens downward. For any parabola, there is a point called vertex. If the coordinates of the vertex is hk, then the axis of symmetry is given by x equals h, and the maximum or minimum value of this quadratic function is given by k. For the x-intercepts, they are just the roots of the quadratic equation ax squared plus bx plus c equals 0. And for the y-intercept, it is just equal to c.